So today we have a theorem, measure of the inscribed angle is half of the measure of the intercepted arc. What actually is an inscribed angle? If you look into this figure, this angle BAC has the vertex on the circle. So if an angle has its vertex on the circle, this angle is said to be inscribed in the arc BAC, and it is cutting off arc BEC. So this arc is called as the intercepted arc, and arc BAC is called as the inscribed arc because the vertex of the angle lies in that arc. So we have the theorem, measure of the inscribed angle is half of the measure of the intercepted arc. This is the way we write it. Measure of the inscribed angle, angle BAC is the inscribed angle, okay, and it is half of which arc? It is half of arc BEC. The same theorem can be put in another way. The measure of an angle subtended by an arc. The measure of an angle subtended by an arc at a point on the circle. Now see, the measure of the angle subtended by which arc? Subtended by arc BEC. The measure of an angle subtended by an arc at a point on the circle is half of the measure of the angle. This angle is half of which angle? Half of the measure of the angle subtended by the arc at the center. This arc BEC is subtending angle BOC at the center, if you can see. So what is the measure of this angle BAC? It is half of measure of angle BOC. And the claim can be put in this manner also. Okay. So for that purpose, we join this AO, we extend it such that it intersects the arc in point E. We will also join OC. Okay. So if we join OC, you get a triangle AOC. This triangle AOC is an isosceles triangle. Why? Because AO is equal to OC. As it is an isosceles triangle, the base angles will be equal. So we call the base angles as X. So this we are going to write now. Join OC. So in triangle AOC, you have AO equal to OC, which is radii of the same circle. Therefore, angle OAC is equal to angle OCA by isosceles triangle theta. Let measure of angle OAC be equal to measure of angle OCA be equal to x degree. Okay. So, for triangle AOC, angle EOC is the exterior angle. Have a look in the figure. For this triangle AOC, which is the exterior angle, EOC is the exterior angle. So you know the remote interior angle theorem, that measure of the exterior angle is equal to sum of the remote interior angles, right? So we are going to apply that remote interior angle theorem. So for triangle AOC, EOC is the exterior angle. Therefore, measure of angle EOC will be equal to x plus x, that is 2x degree, okay, by remote interior angle theorem. Fine. Why I have written twice x? Because this plus this will be the remote interior angle theorem. Okay. In this triangle, if this is the exterior angle, measure of the exterior angle is this x plus this x. So it becomes 2x over here. Okay. Now, similarly, if I take this triangle AOB, again this becomes an isosceles triangle. So measure of the base angle, we will take it as y. So similarly, we will write now. Similarly, for triangle AOB, we can show that angle, measure of angle BOE is equal to 2y degree. Same reason. Now this is your equation 1 and this is your equation 2. To get this angle BOC, we need to add BOE and EOC. So let us add these two equations. Which two equations? Angle EOC plus angle BOE. So we write, therefore, angle EOC plus angle BOE will be equal to what? It will be equal to 2x plus 2y. Reason we'll write adding equations 1 and 2. So now this EOC and BOE makes which angle? It makes angle BOC. Okay, by angle addition property, the two angles give you a single angle, that is angle BOC is equal to, you take out 2 common, x plus y. Fine. Now we take this 2 to the left hand side. Now if you are going to take this 2 to the left hand side, it will become half of angle BOC, which is equal to x plus y. Now come to the figure. What is x plus y? X plus y is nothing but angle BAC. Angle x is angle OAC and angle y is angle OAB. So if you add these two, it will become angle BAC. So here again you will write by angle addition property. So half of angle BOC is equal to angle BAC. Same reason, by angle addition property. Now we have proved this part. Have a look here. Measure of angle BAC is half of measure of angle BOC. Look here. Angle BAC is half of the measure of the central angle. Now I'll have to convert this BOC into this arc BEC. So how do we convert it? Now you know measure of the central angle is equal to measure of the minor arc, right? So in place of BOC we will put measure of arc BEC. So let us put over here half measure arc BEC is angle BAC by definition of central angle. Okay, what is the reason that we give over here? By definition of central angle or by definition of minor arc. By definition of central angle. Hence we get that measure of the inscribed angle. This is your inscribed